In other words, I'm going to integrate 0 on the interval 0 to pi. Okay, so I'm going to, integrate 0 on the interval 0 to pi. Okay, and I'm going to integrate f of x on the interval of 0 to pi. Okay, so f of x sine of x, okay, dx. I'm going to integrate that, and we're also going to integrate this thing here, okay, on the interval of 0 to pi. Okay, of x to the n. Actually, I'm missing something here, am I? Okay. Yes. Well, let's. I've probably made a little bit of a leap ahead here. Yeah. Okay. This is less than this on the upper bound of the interval. Okay, if that makes sense. Yeah. Okay. So the upper bound of the interval is pi, yeah? So actually this thing here, when we put in the maximum value for x, okay, that can take on the interval, which is going to be a value up to pi, yeah, okay? This here becomes pi to the n times a minus b of pi raised to the power of n over n factorial. I made a little bit of a jump ahead here, yeah, okay? Which now by definition this is less than pi of n times a to the n over n factorial. It's the same thing here, just evaluated at pi. So that is less than that, if that makes sense. So actually this here is going to actually be, it's the integral of this thing here should be pi, okay? So it's pi to the n of a to the n over n factorial dx, okay? So when we integrate this, now the definite integral of 0 was just 0, okay? Let's just leave this is, because we figured this out earlier on, yeah, and we found out that it's an integer, yeah, okay? So the definite integral, so what we end up with is that this particular inequality becomes, so let me write it down again, it's 0 to pi of 0 dx must be less than 0 to pi of f of x sine of x dx, okay, which must be less than the integral from 0 to pi of pi to the n a to the n over n factorial dx, okay. This here goes to 0, so this gives us 0 is less than, let's leave this as is, so it's 0 to the pi of f of x sine of x dx, okay. Now this thing here, well, this is just a constant. So the integral of that particular constant is going to be, it's going to introduce back in the x, yeah, so this becomes pi to the n, a to the n, all over n factorial times x, and that's to be evaluated on the interval pi, 0 to pi, okay? So actually this becomes 0 is less than 0 to pi of f of x sine of x dx, okay, is less than, you know, when I evaluate that at pi, that becomes another pi times, that gives us, it's going to be pi to the pi times a to the n, okay, over n factorial. I just took the n out here, yeah. I just we exponentiate across the product of the pi a, yeah, to give us this here times, now the x becomes pi, so it's times pi. When we put 0 in, the thing falls away, so it gives us this particular inequality here. Now another important observation is this, is that as n gets sufficiently large, yeah, okay, as n gets sufficiently okay, large, okay, well, this particular term here, okay, pi of a to the n over n factorial, okay, it actually tends to 0, okay. It converges to 0, this particular term does, yeah. And actually this is from the fact, okay, so this is from the fact, okay, that the exponential function e to the x, okay, which can be defined as this series, okay, the summation, I'm not going to do any limits on the summation here, x to the n over n factorial. We know that this particular function here converges to 0, okay, as n gets larger and larger, as n tends to infinity, okay, that converges to 0, okay. So when x is equal to pi of a, okay, we have that e to the pi a, okay, it must be equal to this series here, okay, evaluated pi a to the n of n factorial must converge to 0 as n gets sufficiently large, okay. In other words, this thing here is going to 0, okay, that's going to 0, that particular term is here. And actually now what we can see is this is sandwiched, yeah, okay. So hopefully we can actually see what's actually happening here is this. Let me write it down again, just one more time, just nearly there with this particular contradiction, okay. Geez, well, this is 54 minutes walking through this here, but I hope this will be helpful for somebody, out there, so let's just write it down again. So we have 0 is less than the integral from 0 to pi of f of x sine of x dx is less than, we said, a to the pi to the n over n factorial times pi. Okay, so what have we got? Well, this thing here is tending to 0. Okay? That's going to 0. Okay? But we've already shown, okay, we've shown that this thing here, okay, that this, okay, is an integer. Okay, we've shown that it's an integer. Okay, actually, if we just roll back there, okay, where does that gone to? Okay, we've shown, okay, there you go. We've shown back here, okay, there you go. We've shown that this thing here is an integer. Okay, in effect, it's f of pi plus f of 0. It's an integer. Okay, so what the hell is happening here? Yeah, this thing is getting closer and closer to 0. So actually, at some stage, if you think about it from a number line perspective, yeah, here's 0. This function is an integer, so this function is over here somewhere, okay? But this is going to get smaller and smaller and smaller and smaller. Eventually, it's going to get by 1, okay? And it's going to get smaller and smaller and smaller, and it's going to keep sandwiching this particular function, yeah? So this function is going to continually get sandwiched and sandwiched and sandwiched, which it can't do because it's an integer. We've already shown that it's an integer that's out here, okay? And what we've actually arrived at here is a contradiction, yeah? Okay? So this is a contradiction. Okay, it's a contradiction. Okay, and this contradiction has arisen, yeah, from our assumption, okay, which has arisen, okay, from our assumption that pi is equals a over b is rational. Okay, that was our assumption, and therefore, pi is irrational. Okay, that's our proof. Okay, now a lot of detail in here. As I said, Niven's proof didn't go into so much detail and assumed the actual knowledge in relation to all of the important steps. Niven's proof is a single page. Wow, I must have used about 10 pages here to try to, probably even a little bit more, 10 pages to try to rationalize and get across actually what's going on under the hood. Look, I'm sure there is a lot more detail, yeah, okay? My rigor, I haven't been very rigorous here in relation to actually getting really defining things and getting them stuck down, yeah? But all I'm really trying to get across here is my understanding of actually what's going on in relation to this particular proof that pi is irrational. So once again, guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope that this video was in some way helpful, and more importantly, whoa, that was long, yeah? So thank you for watching. Okay, bye bye.